Hello, this is our open source Linux infrastructure presentation created by Karuna, Roblin, Mandeep, Meet Kumar, and Hamad. Summary of requirements. The project aims to develop, deploy, install, and manage an open source Linux infrastructure that fulfills the requirements of several service implementations. It describes the implementation strategy of creating an LFS machine to use as a base image for cloning. The base image will be cloned several times to fulfill the needs of other server requirements for the project duration. Creating the infrastructure design, determining appropriate open source tools, building the infrastructure, and guaranteeing its stability and scalability will all be part of the project. The task includes establishing a server environment, configuring suitable software, protecting the server, and monitoring its functioning. This is our demonstration of completion. Okay, so for DHCP, I installed ISC DHCP on an Ubuntu system. This package allows you to automatically assign IP addresses to devices in your network. So to show you that the package is working, I'll show you the status of the system. And you can see that it's running, and you can also see that it's given out some leases down here. Next, I'll show you the configuration file to show you what I've configured to make this DHCP work. So I put my personal subnet as the subnet that I'm going to be using, and I chose the range from .70 to .75. And I also put in my personal subnets router. And then to show that it is working, I can show you the leases file. And you can see here that it's given out the .71 IP address and .72 and .73 on 3 different client devices. So that is the DHCP server. So for our block IO server, I decided to use iSCSI. It's a package that allows you to access block level storage items on client devices in the network. In order for this to work, we need a target and an initiator. So this is my target VM right here with the IP address of 10.172.65.67. And I can show you the status of the target. It is active and running. Next, I'll show you the target CLI, which is the place where you make all the configurations for your iSCSI. I have a TPG created, a map-LUN, and a portal. You need all of these in order for an initiator to access the block level storage items. And then now I can show you that it is listening to itself. And also a session is created for the target. So if we go over to the target, we can run this command right here to show that it is connected to the initiator. And then we can also run this command lsvok to show that it is able to view the block level storage items on the target device.
Hello, everyone. So today I'm going to discuss the 2 services that I created. So the first one is the database server, which I use Postgres as a database. So this is the actual dump of the database in this screenshot. Okay, so first things first, before accessing the database, you actually need to change the user. Depends on what a user who is the user you use to create a database. So in this case, I use Postgres as the user instead of root. So in order to change from root to Postgres user, you should access or input the syntax su-postgres. So meaning change user to Postgres. So in order to access the Postgres database itself, you need to input PSQL, then enter. This will directly go to your PSQL database. Then in order to list all the to list all the databases, you need to input the command \l, meaning list all the database. So after listing all the database, you should pick one database that you want to access or switch connection to. The syntax for that one is \c then the database name. In this case, I will be using test as the database that I want to access. So in order to do that, you should input \c test name of the database. Then after inputting that, this will directly go or access your database. Then in order to like show all the list of tables inside that database, you need to use the command \dt, meaning list all the specific tables in that certain database. Then since you have all the access, or you already have all the list of the database, the tables inside that database, to access or show all the data inside that table is by using the command select, which is like selecting all data inside the table or show all info for that table. So the command for that is select asterisk, then the then the table name. So in this case, I will be using T1 as my table name under the test database. So select asterisk from T1. So in that case, it will show or select all the data inside the table, regardless of what column is that. So yeah, I guess that's it for my database. Then for my remote access server, this is the second server that I installed in my LFS. So I use OpenSSH to access any remote servers. The command I use in order to access any VM based on this screenshot that I'm providing is SSH root at the IP address. So root is the user, and at IP address is the IP address of the VM that I want to access. So it's basically very simple. It's just like we've done this multiple times already in our class. So the command is just SSH user, name as user at then the IP address. So in that case, in my case right now, I'm using SSH root at 10.172.52.65, which is the IP address of my VM, and the root is the username that I'm using for that certain VM. So after inputting this command, it will show the authenticity of the host. Then it will ask, are you sure if you want to access that VM? Then you should input yes in order to like log in. Then after inputting yes, it will ask for the password. So just make sure that you know the user and the user and the exact password for the VM you're accessing. So yeah, so this is like the actual screenshot, since I can show you the VMs or the vSphere right now because we can't access it. So this is the exact image of what you will be seeing if ever you're accessing any VMs. So both of my services are running under LFS. So yeah, I guess that's it. Thank you.
So for performance monitoring and system management, we chose Prometheus. So on the high level installation, I followed the steps in setting up performance monitoring. So server build and configuration, installation and configuration of the Prometheus application, and the installation of Node Extractor. So how does it works? Prometheus app will be the one that will collect and store metrics from the servers and provide monitoring. And the node extractor will be the one who will export the server and OS level metrics such as CPU, memory, disk space, and more. So for the steps of installation and configuration, first, I built the server using the template for Ubuntu 2022.04 and assign the proper IP range. So this will be your assigned student IP network. And second, I updated the system packages and installed the Prometheus application on the server. I created and edited the Prometheus application configuration file to add the node extract job and include all the servers I needed to monitor. And then I allowed the port 9090 for the Prometheus application to be accessible. Then second, I installed the node extractor on the servers that I will monitor and update the firewall configuration to open the port 9200 that Prometheus needs to establish the connection. So this node extractor will provide data to the Prometheus application. And once Prometheus and node extractor has been installed and configured, you may go to the Prometheus interface to browse the targets and select metrics that your organization's needs, such as CPU, memory, disk, and more. So this is the GUI for Prometheus that displays the server utilization, and this graph shows the CPU only. So for our basic ticketing system, we select the ITAP application, and on the high level, I follow the steps in setting up performance monitoring. So server build and configuration, installation of ITAP prerequisite and web codes, configuration of ITAP application. So initially, I built the server using the template for Ubuntu 22.04 and assigned a new IP. Then second, I updated the system package and installation. And installed the prerequisites of ITAP, such as installing MySQL and performing the creation of DB, creating users and providing permissions. Once done, I also installed Apache 2, PHP, and its other components. So there are some configuration files I also updated under the PHP. Then I downloaded ITAP web codes extracted from a folder dedicated to it. Provided proper permissions and restarted the Apache services. Then last is I proceed with the ITAP user interface installation, providing all the details required, such as the database, admin account, service accounts, and many more. And after configurations, I log in as admin that I configured in the configuration phase. So this is the GUI for ITAP applications.
So for DNS server, I choose bind package. The bind package provides a DNS server and client utilities. It is responsible for translating domain names into the IP address that computers use to communicate over the network. So there were bind dependencies, some were required and recommended, which were needed to install. So the installation for the packages and the dependencies was done by using some commands like wget and tar functionalities to get them and make and complete the installation. So I installed bind by running some commands and then issued the commands to run the complete suite of tests. To run the test as an unprivileged user, I executed make-q check command and again as root cleaned up the test interfaces. Finally, I installed the package as the root user. Then I configured bind, created the unprivileged user and group named, set up some files, directories, and devices needed by bind package. Then completed the name.conf file, created the root.hints file, and then to start the DNS server at boot, install the init script included in the BLFS package. The command here, it shows all the required and recommended packages which were installed. So the names and the versions of all the packages are displayed here using this command. The next command, it shows the bind package has been installed, its name, its extended support version name, it's been displayed using this command. Then the next command resolve.conf. It shows the current DNS configuration on our system, the DNS servers that our system is using for name resolution. The next command, it contains the root.hints file, which is a list of root name servers that our system is using. Then the next command, it shows zone files created, including all the content. Here we made a network connectivity in order to check. So we did a ping test to the loopback interface and to the public DNS service, and both were successful. So this all commands showed the successful implementation and installation of bind package in order to implement DNS service. For certificate authority, I chose EasyRSA. So EasyRSA is a set of scripts and utilities that simplifies the process of setting up and managing a public key infrastructure, PKI for a certificate authority. It generated a public key and a private key root certificate. So here it shows the directory which we first created that contained all the files that were needed to create a certificate authority. The steps which I followed in order to install it were: first I installed EasyRSA, then I prepared a public key infrastructure directory which contained all the files to create a certificate authority further, then created the symlinks with the commands, then initialized the PK inside the EasyRSA directory and created the certificate authority, and finally distributed the certificate authority's public certificate. So here we can see nanovars. We created and edited a file called vars with some default values. Then to import the CS public certificate into second Linux system like some another server or a local computer, we first obtain the copy of ca.cert file from the CA server. So here it shows begin certificate and till the end of the certificate, that was the copy of the ca.cert file. Then we could check for the presence of the CA certificates package using these commands, and also check the EasyRSA environment initialization that the public key infrastructure directory present or not. So here it shows the name, version and description that it has been present here. Then in order to check the certificate authority is created, this command EasyRSA show CA was used, and it shows everything including its version, serial number, name, expiration date and many other details. The most important was common name, that is EasyRSA CA. So this shows all the successful implementation of the certificate authority service. That's it.
So hello, good morning everyone, and I'll be moving on with the last bit of the presentation for group 3, and I'll start by sharing my screen. So I'll be talking about the File.io server and the Samba implementation. That's what we chose for the service which we are going to use on the LFS system. So firstly, we'll try to understand the File.io server and what Samba is basically. So to begin with, let's first understand the concept of File.io server. Imagine you have multiple devices like computers and smartphones, tablets on your office area, and these devices want to share their files to each other, but they don't have a native understanding of each other's file system, right? So, and this is where File.io servers come into place. And first, we'll try to understand what is Samba. So Samba is one of a popular File.io server solution that is open source software and which suits like on different operating systems such as Windows, Linux, and Mac OS to share the files and resources seamlessly. And essentially, Samba acts as an intermediary and translating file requests and managing the communication between devices using different sharing protocols. Moving on. So the key concepts of Samba. So when I was configuring Samba, I configured looked at this understanding, like these were the concepts I took to understand the stuff. So there's SMB protocol, Samba protocol, which is the server message block protocol. This is the foundation of Samba. It's a network communication protocol used for sharing files, printers, and other resources. So Samba allows like printers to be also in a sharing protocol as well. Samba server, this is the heart of the Samba. It allows computer to act as file server. Samba client is the device which wants to access the shared resources on the server. And then there's a configuration file, which is the main part, which Samba's configuration file is where you define the settings, such as shared directories, permissions, and authentications, right? So looking at the benefits of Samba, so Samba is firstly cross-platform compatible. As I said, it works on different multiple operating systems, which break down barriers to communication and collaboration. Centralized resource management. Samba allows centralized management of shared resources, as there's just one file IO server, which maintains the whole directories and stuff and the files. It's cost effective as it's open source solution. Obviously, Samba is cost effective and does not require any license fees, which makes it excellent choice for our project right now. And the business scalability, Samba can be scaled to accommodate growing networks and increasing files, right? So it has no limits on that. So this is the proof showing Samba is working. So first I went to the Samba configuration file. As you can see the path here, this shows the IP I entered and the directories which I had access to, which is the public folder. By default, you get the access to. So I didn't create a specific folder for it, but it can access the IP and look into the folders and add any files they want, or they can read it. So in conclusion, file IO servers like Samba are crucial in modernizing data sharing, enabling devices with different operating systems to collaborate effortlessly. With its cross-platform compatibility, centralized management, and cost effectiveness. Moving on, next is the NAC server and the Zabbix implementation. So we used Zabbix for our NAC systems. First, we'll try to understand what is NAC server and Zabbix and the key functions to it. So firstly, NAC is network access control. Imagine you have a network with multiple devices like computers and IoT devices. So NAC is like a security bouncer that checks each devices before allowing it onto the network, or like a gatekeeper, you can say. And what is Zabbix? Zabbix is an open source monitoring tool that helps manage the health and performance of networks, servers, and applications. And it acts as a vigilant observer, so you can track and you can analyze the traffic going in and out your environment. Key functions of NAC server is authentication and authorization, endpoint assessment, network registration, policy enforcement, quarantine remediation, real-time monitoring. Benefits of NAC. So NAC offers various benefits. Firstly is enhanced security. NAC prevents unauthorized access and protects against potential threats like malware and unauthorized databases. So you can block the stuff from entering your environment. Compliance. So you can set rules to have the devices compliant to your policies and other stuff. Network visibility. NAC provides insights into the devices connecting to the network, aiding in better management and security decisions. Zabbix benefits will be it is proactive in issue resolution. So Zabbix provides real-time alerts, which enables IT admins to know where there's a downtime or stuff like that. Resource optimization. So Zabbix aids in optimizing network performance and resource allocation. Historical analysis. So it can show you the trend and help you predict what can be the bottleneck in future. So moving on, next is challenges and resolutions you made. So the only challenge you encountered during the work project was the LFS creating issue. Like we had this issue called error disk HT11 not found. And this was like my main thingy when I was doing the project. I had like 3 to 4 attempts doing it. In my last attempt, I had created one LFS server, so that was nice. Although, but talking about the challenge we had, it was this HD11 thing. So it's basically the fstab configuration file where you don't maybe have not written the file correctly, and it might not work in booting up the image. So what I just did is to retry again, like retry multiple times and then had it work in the last attempt. So I had also tried boot repair as a solution, but it didn't work. So I just left it and move on in creating it again. So that was it about creating the LFS and the challenge we had as a group. Key factors. So project goals and objectives. So making decisions on the scope, scale, and complexity of the infrastructure to be built is aided by having a clear understanding of the project goals. So basically, all our team members had a clear understanding of the goals we are having, and everyone knew what he or she was doing. Resources. The selections of technology systems and services to be deployed can be influenced by the availability of hardware and software, right? So we all like have been using technologies. We integrated like Microsoft Teams, OneDrive, Microsoft Outlook for like communication and collaboration purposes. We backed up all of our files on OneDrive. So that's like utilizing the resources effectively, right? Time frame. So time frame is one of the main key factors in every project, because time is a finite resources available out there. So the project deadline or timetable can have an impact on choices regarding the amount of information contained in the project plan. So this was one of the main factor in our project, because we had already delayed LFS like creation, but all my team members were proactive and had all the documents ready by that time, and we just had to take some screenshots and go ahead and submit and just get it done. Technical requirements. So determination on hardware requirements, software choices, and configuration might be influenced by the precise technical requirements for each services, such as DNS, DHCP router, and other servers out there. Lastly, thank you for this presentation opportunity, and I invite all of you to share your thoughts and questions if you guys have. And thank you for once again for having us here from Group 3. So bye bye and have a good day.